Hi, welcome back to another video. Today we're going to take a look at the laws of indices. Remember, an indice is a power, so if you have a number and you raise it to a power, this tells you how many times you're multiplying that number by itself. So as an example, we know that 2 squared equals 2 times 2, which equals 4. Now, the laws of indices tell us how to multiply, divide, and various other operations on indices. We can have fractional powers, we can have negative powers or indices. So hopefully in this video you'll understand those rules. The first one tells us how to multiply two numbers which have the same base but their powers are different. So as an example, 2 cubed times 2 to the 4, well, we can write this out in full. So 2 cubed is 2 times 2 times 2. Let's put it in brackets for ease. And we're multiplying by 2 times 2 times 2 times 2. Now how many 2's have we got in total here? Well, we've got 1, 2, 3, 4, 5, 6, 7. So this is just going to be 2 to the power of 7. And in fact this works on all numbers. So a to the m times a to the n, well, you just add the powers together. That's our first rule. Another example, let's do 3 squared times, 3 to the 5. This is 3 to the 2 plus 5, which equals 3 to the 7. So that's rule number 1. Okay, rule number 2 is division. It tells us how to divide two indices that have the same base and powers. So again, another example, let's see what's happening here. So this is 3 to the 4, which is 3 times 3 times 3 times 3. And we're dividing by, so I'll write it like this, 3 times 3. Now, we know that we can cancel anything that appears on the top and bottom because of this rule. Anything divided by itself is 1. So we can cancel 2 3's from the top with 2 from the bottom, and this just leaves us with 3 times 3, which is of course 3 squared. So the basic rule, a to the m divided by a to the n equals a to the m minus n. So basically the m minus n means you're cancelling whatever's on the bottom with whatever's on the top, and that's what you're left with. So that's the second rule. Okay, the third rule tells us how to multiply an indice by a power that's on the outside. As an example, 5 squared to the power of 4. So remember, if this 5 squared was any number, we would just do that times by itself 4 times. So that's all we're going to do here. 5 squared times 5 squared times 5 squared times 5 squared. And now we can just use rule number 1, which says a to the m times a to the n equals a to the m plus n. So let's use that. Well, this is just going to equal 5 to the 2 plus 2 plus 2 plus 2, which equals 5 to the power of 8. So our basic rule, a to the m all to the power of n equals a to the m times n. Another quick example, let's do 2 cubed squared. Well, this is going to be 2 cubed times 2 cubed. And by rule number 1 again, 2 to the 3 plus 3, which equals 2 to the 6. So all you do is multiply these two numbers, and your base number remains the same. So that's rule number 3. Okay, rule number 4 is called the reciprocal rule. And this tells us how to deal with negative indices or negative exponents. And what it says is that if we have a number a raised to the power minus n, then this is just the same as 1 divided by that same number, but with a positive exponent. So an example, 3 to the minus 2, or 3 to the power of minus 2, is just going to be, using our rule, 1 over 3 squared. We know what 3 squared is, it's just 3 times 3, which is 9. Okay, another example then, quickly. 2 to the minus 4, well, it's just 1 divided by the base number with a positive power. Again, we know what 2 to the 4 is, it's just 16. So 2 to the minus 4 equals 1 over 16, like so. That's our rule number 4 there. Okay, rule number 5. So this is all about fractional powers. So I'll write that down, or fractional exponents, or fractional indices. So it says a number a raised to the power 1 over n is equal to the nth root of a. So I hope that makes sense. So in this case, 81 to the power of a half, well, this just equals 81, and it's the square root of 81, which we know is 9. Let's look at another one. So let's do 27 to the third. Well, using our rule, this is just 27, but it's the cube root, which we know is 3. Now, what about if we combine rules number 4 and 5 and we have something like this? 27 to the minus a third. Well, using rule number 4, we use the reciprocal. So this becomes 1 over 27 to the third. And from our little example here, we know that 27 to the third is just 3. So that's how you'd combine a negative and a fractional indice. Okay, and we could take this even further by combining another rule. So let's look at 27 to the minus 2/3. Well, this is just equal to 27 to the minus third squared. Yeah, because by rule number 3 here, if we have a number raised to a power and then another number on the outside of the brackets, we just multiply the two powers. So 27 to the minus 2/3 is just equal to 27 to the minus 1/3 squared. Yeah. And we've just worked out here what 27 to the minus 1/3 is. It's just a third. So our answer is a third squared, which is simply 1/9. Okay, so that's sort of combining a few rules together. Maybe I'll write that down. So this combined rules 4 and 5. This one combined rules 3, 4, and 5. Okay, our final rule is quite a simple one, but you should take the time to learn it. It just says that any number raised to the power of 0 is 1. So any number to the power of 0 is 1. And let's have a look at an example here. So what happens if we divide 2 squared by 2 squared? Well, we know this is just 2 times 2 divided by 2 times 2, and as usual we can just cancel, so we're left with 1. But how about if we use rule number 2, division? So I'll write that down. How about if we use that rule instead? Well, that just says 2 squared divided by 2 squared is equal to 2 to the power of 2 minus 2, which equals 2 to the 0. But we've just shown here that 2 squared divided by 2 squared is 1. And this is where this rule comes from. So anything to the power of 0 is 1. Just as a final little note, as a sort of rule number 7, but if you can't remember this, then don't worry about it too much. Any number to the power of 1 is just itself. Yeah, and hopefully you can see why that's obvious. Okay, great.